Hello, everybody, and welcome to our second chapter in this class. It's Fractions 2. Make sure you have the correct book. And it's a continuation of our last lesson. And let's go see what we have in the word bank. I'm just going to give you an overview in the beginning, what you have to do for homework and which parts I'm giving you for notes. The word bank is always notes. So put that word in the corner of your page. Then this one right here is going to be actually an extra assignment I'm going to make. It's for you to try to figure out, and I'm going to make it a special assignment on, so it's going to get a special grade if you can figure it out. So when you come to class and you have figured out this question, see me and show me your answer and how you did it. Or you can take a photo and email it to me. And then you will get that special assignment points. I'll just have it on Canvas as the Super Math Squad question. Okay, so that's homework. And it's about how many pizzas you have to buy. If everybody wants a fraction of a pizza, you have to figure out how many of each pizza, veggie and pepperoni, you have to go buy. So I will not help you on that one. And mental, this one right here is notes, I believe. Let me check. Nope, actually I'm having this as homework. It's pretty simple, so not much help needed there. So you just read the instructions and answer the questions. There's 4 questions, and it's about these 4 numbers right here. Okay, so that's homework. Oh, I have a multiplication chart for you here because it's going to help you finding the common denominators. So you can always print one out on the internet, or you can, hopefully you know your multiplication facts, but if you're having a hard time with it, or I can give you one in class, remind me, okay? Then this page right here, we're on page 3. Yep, page 3 is going to be notes. Page 4 is notes and homework. So parts, and I believe down here, this is going to be homework. These questions. Then we're on page 5, and this is notes. Page 6 is homework. Page 7 is notes. And this is page 8, and that's homework, and that's as far as I got. So this is my first lesson for lesson 1. You're going to have 3 videos, 3 lessons in this book again. Okay, so let's go back to the very first page, note bank or word bank. My word bank, okay? So again, all those words are in the back of the book for you to look up if you need to. Common denominator. A common denominator is, remember the denominator is always the bottom of the fraction. So it's the common denominator of 2 or more fractions, usually it's 2 fractions, sometimes it's more, is divisible by each of the denominators. And I'm going to give you an example because that sounds very difficult, very confusing. So, and most of you have already heard that and know it, 1/2 and 2/3 common denominator, I'll just call it CD because I don't want to write too much, is 6. And why is that? Because 6 is divisible by 2 and 6 is also divisible by 3. Okay, that's what the common denominator is. Let me give you a clue. It usually is higher than both of the denominators. If they're different numbers, the common denominator is usually bigger. Not always. Okay. Difference. The word difference is the result of subtracting. So it's a takeaway problem. Sometimes you use those words because they're elementary school words, but we're now starting to get into higher classes. So we want to be more formal. It's the result of subtracting. Estimating is an educated guess. An educated guess is something you have a clue about. It's not like you are totally clueless. You have a little idea. That's called an educated guess. Sometimes we say is about. It's about is an estimate, and the symbol is these 2 squiggly marks. Okay, that's about. The multiplication property of 1 says that when you multiply, let's write that, when multiplying, multiplication property of 1, when multiplying by 1, the answer doesn't change. You can multiply by 1 and it will not change what you started out with. Oh, not the answering. The answer does not change. And for example, I'll say, I'm making up a number. Let's say 4 times 1 is still 4, right? By the way, when we get now in higher classes, we don't use the x for times because that's pretty soon you'll see that that's called a variable and an unknown number. So let's use the multiplication dot, or you can use parentheses. You can also write 4 times 1. That's another way to write times. Okay, no more x for times. We're going to grow out of that. The lowest common denominator. Okay, look, we got the common denominator, but then we can find the lowest. For example, let me give you an example up here. You don't need to write that down. Let's say I have the number 3, some 1/3 and 1/4. Well, I can say, okay, a common denominator is 24 because 24 is divisible by 3. Yeah, 24 divided by 3 is 8. And 24 is divisible by 4 because 24 divided by 4 is 6. But that's not the lowest common denominator because the lowest number would be 12. And because 12 also is divisible by 3 and 12 is also divisible by 4. So the lowest number is what we usually want. If you don't find that lowest number, if you just find a common denominator, you're going to create yourself a little more work because you'll have to reduce your fraction in the end, but it's still going to be correct. It's not wrong. Okay. All right, so let's see what we have. Lowest common denominator. It's called the least common multiple of the denominators. Remember, you have two or more. So let me put some multiples here. That's why a multiplication chart is so handy. I'm going to find the multiples of 5 and write them here. And then I want to know 5 and 2. Between 5 and 2, what's the least common multiple or least common denominator? So I'm writing down all the multiples of 2. And then when you get to one where they match, they are this one is the lowest. Yeah, so you can write down all the multiples and you find the first one that matches. So this would be an example. Let's say 2/5 and 1/2. Lowest common denominator is 10. Another way to do it is just multiply 2 times 5. That works, but it might not be the lowest. That's the only thing. If you just multiply them, you will find a common denominator, but not the lowest. In this case, it worked. Okay, so equivalent fractions have the same value. So when a number has the same value, it takes the same place on the number line. That's what the same value means. Same place on the number line. The number line has a spot for every number in the whole universe. Every number that you can think of has its own unique spot that it doesn't share with any other number. But if they're equivalent, they will share it because they're the same number, okay? Same place on the number line. Well, sometimes you don't recognize that. For example, if you have a fraction like 1/2, the same value, it would be 2/4, because 1 out of 2 is the same as 2 pieces out of 4. Yeah, so these are the same or equivalent fractions. Sum is the result of adding. And a word of my choice that I came up with was improper fraction, because in this, or in the last lesson, we had to deal a lot with improper fractions and mixed number. So an improper fraction is when the numerator is larger than the denominator. You see that? The numerator is larger than the denominator. That's not proper. The other one, that when it is a proper fraction, this would be smaller than the denominator. So we can make it turn it into a mixed number. So I can say, how many times does 8 go into 10? It's 1 time with a remainder of 2/8. And now I can say 2/8 is the same as 2 out of 8 pieces is the same as 1 out of 4. And this is called a mixed number. And this is, by the way, heavily on your last test that you just took. And there was an IXL assignment on it. So I always encourage my students to make sure they have all their homework completed and check that it's correct and finish all the IXL assignments before taking a test, because it's going to help you a lot, okay? All right, now we're going to go on to the next page. And that is the page where you have to figure out the answer, and you can email it to me, a photo. Make sure you show me how you figured it out. It's about, you're going to buy pizza and how many do you need to buy if everybody wants a certain fraction of each pizza. Okay, so think about that. And that, like I said, that's going to be another assignment I'm going to add to Canvas where you can earn extra points. The next page is page 2, and it's already homework, so you can finish that on your own. Make sure you read what it says. Here are 4 numbers. Describe why each one might not belong with the other 3. So your job is to figure out which number is a little different and why. And then you have to explain why, what makes it a little bit different. So I would say that these answers, there's really no right or wrong. Everybody might see it in a different way, but I want you to think about it. Then we have a multiplication chart, and these are the multiples. If you say, oh, what are the multiples of 3? Well, you can go down vertically, that's called, and you will have the multiples of 3. Or you can take it on the side here and go horizontally and find the multiples. And that is very helpful when we do our common denominator, okay? So I'm gonna come back to this multiplication chart. The next page is page 3. Everybody ready for notes? Okay, so it says using section 2.5, which is the end of the book, write an explanation, an example of the word estimate. We already done that. Yeah, it's about an educated guess. That's what that is. In my word bank, done. Then estimate the location of each number on the number line. Okay, so we start with 0, it's in the beginning, and I'm going to put 1 at the end. So all my numbers here will fall somewhere on this spectrum between 0 and 1. Your job is to figure out how close is it to 0, how close is it to 1. 1/2 is always the easiest because you just cut it in half. Correct? 5, 6, so you have 5 parts out of 6 parts. So you almost have 1. It's close to 1. You remember the symbol is about, because we got most the parts of the 6 parts there. So I'm going to put it close to 1. Okay, 3/8 is close to 1/2 because you have 3 parts out of 8 parts. Had you had 4 parts out of 8 parts, it would be 1/2. So this is going to be close to 1/2, but less than 1/2. So I'll say close to 1/2, but less than 1/2. Remember, this symbol means less than, but not much. 3/8 maybe right here. So that's my estimate. Okay. What number did you choose first? Of course, 0 and then 1. That's always the beginning and the end. That's your spectrum. And then I always like 1/2. Cuts it in half, right? Explain how you located 3/8, a little less than 1. No, a little less than 1/2. Because 4/8 is equal to 1/2. And 3/8 is a little less than 4/8, right? Number 2, 3 friends want to share 5 brownies so that each gets the same amount. How much can each friend have? Show with a diagram. Write the result as an improper fraction and mixed number. Remember, that's why I showed you that on the word page. All right, so we need to have 5 brownies. So I'm going to draw some brownie rectangles. And then I want you to think about how many parts do we have to cut each brownie in. 5 brownies. Yeah, 1, 2, 3, 4, 5, but 3 friends. So that's the parts. So I can cut each brownie into 3 equal parts. And then each friend gets one part because there's 3 of them, right? And that other friend gets this one and the third friend gets that one. But I want to know how much each one friend gets. Okay, let's think. How much would that be? We can think to put this one here and this one here. That would make it 1 brownie, right? And then, so that, if we take that one, put it here, and that one would be, we have 1 whole brownie, and then this one and this one would be left over plus 1/3 plus another 1/3, right? Well, the 2 1/3, if I put that here, that would make it 2/3. So 1 brownie plus 2/3 of a brownie. So that would be 1 and 2/3 for each friend. So that's your mixed number, but it also says improper fraction. So this is your mixed number. So the improper fraction would be 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. So I'm going to have to figure that out on the side margin here. Does it? Let me see, where do I have room? I'm going to have to work my way up here, okay? So this is 1/3, 2/3, 3/3, 4/3, 5/3. 1, 2, 3, 4, 5/3. This is your improper fraction. Okay, so we got the improper fraction and the mixed number. So when we use mixed numbers, we do because it's easier to understand. It's hard to understand how much this is to each kid. So you say, oh, everybody gets 5/3 brownies. Nah, what would that be? But everybody understands each kid gets 1 and 2/3 of a brownie. That's why we change these improper fractions to mixed numbers. All right. Okay, next we're going to do the big one again. Now remember, the big one helps us to decide what we have to multiply or divide to make it the bigger fraction. When it's a bigger fraction, it's expanding. Otherwise, it's called reducing. This is reducing, this is expanding. So 3 to 6, we're going to multiply by 2. 3 times, see, they have the x here, which it's okay, but we want to get away from that. 3 times 2 is 6, 1 times 2 is 2. So these are equivalent fractions, okay? So now we don't need that 1 shape, we're just going to times 20 times what is 100? It's 5. 20 times 5 is 100. So this is your big one. 3 times 5 is 15. And 9 times what is 3? Oh, this is a division. This is reducing. Do you notice? It's getting smaller. So it's a division. 9 divided by 3 is 3. 30 divided by 3 is 10. So this is called expanding, and this is called reducing. Simplest form, reducing. So our answer, 12 divided by 4 is 3. 16 divided by 4 is 4. This is in simplest form. So now we have to decide, what are we dividing by? They're not giving us a clue, right? But I noticed both numbers are even. So I can always divide by 2 because even numbers are all divisible by 2. But I'm going to go to my multiplication chart. So we're looking at 8 and 12. 8 and 12. Or I'm trying to figure out how to show that to you, how to explain that to you. So 8 is divisible by 4. Do you notice 8 is a multiple of 4? And 12 is also divisible by 4. So I'm looking at this right here. 8 and 12, those are my numbers. They're both divisible by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So I can divide top and bottom by 4 and have a reduced form. 8 divided by 4 is 2. 12 divided by 4 is 3. And 2/3 is simplest form. Let's try that again. Unless you have a good number sense and you're really firm in your multiplication, you might see those numbers right away. Oh, yeah, okay, divisible by 3, but you might not. So let's go back to our multiplication chart. Which were they? We're looking at 12 and 21. Oops. So let's look. 12. I see a 12 here. And I see a 21 here. So they're both divisible by 3. So you're looking where you have the same column or row. It could be a row. If you go look at 3s, you have the same thing, 12 and 21. It doesn't matter if it's row or column, but notice they are both multiples of 3. So now I know I can divide by 3. And then I have a reduced fraction. So 12 divided by 3 is 4. So I go this way and I see the answer. And 21 divided by 3 is 7. This is how you can read it. So 4 and 7. So my big one is 3. 12 divided by 3 is 4. 21 divided by 3 is 7. And this is my reduced or simplest form. Rewrite both fractions with a common denominator. This is probably the hardest exercise in this book for you because I have seen many, many high school students stumble over that. They still don't know how to do it. So I want to make sure you guys understand that. And it's not that easy. The common denominator is the number that is divisible by 2 and by 8. And we want the lowest, but it's not always lower than the numbers. It's usually actually higher than the two numbers. So it's a little confusing. Rewrite both fractions with a common denominator, circle the fraction with a greater value, and we already have the explanation, okay? So we're looking for the common multiple of 2 and 8. All right? Now, remember I told you, you can always multiply. 16 is a common denominator. Is it the lowest? No, there's one lower. So I'm going to show you how to find the lowest. So you write the multiples of 2, and you can look at your multiplication chart, and then the multiples of 8. And when they match, That's your lowest common denominator. So 8 is your lowest common denominator. 8 is divisible by 2, and 8 is divisible by 8. Okay? So the multiples, as soon as they match, you got the lowest. It's called the lowest common denominator. Okay. And then we need to rewrite the fraction. Okay, so this is tricky too. If I want to go from 1/2 to 8, what am I multiplying with? What's my big one? It's 4, right? 2 times 4 is 8. 1 times 4 is 4. So I have 4/8. And then from 5, I'm going to move that over a little. From 5/8, oopsie, 5/8, and I want to go, oh, that's the same. I'm already there. My denominator is the same, right? So which one is the circle, the fraction with a greater value? I need to take my circles off because 5/8 is the bigger fraction. 4 out of 8 pieces is not as big as 5 out of 8 pieces, correct? Think of a pizza. If you slice a pizza into 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8. Wouldn't you rather eat, if you could, or let's say it's something you're really hungry, if you have 5 slices, that's more than 4 slices, right? 4 slices is 1, 2, 3, 4. 4 slices out of the pizza are not as big as 5 slices out of the pizza. So there you go. And next we have 4/5 and 3/4. We want the common denominator. I'm going to make it even a little more challenging. I want the lowest common denominator. You can always say a common denominator is 20 because 5 times 4 is 20. And in this case, it is the lowest because if you look, if you write the multiples of 5, and then I'll just stop here, and then the multiples of 4, I'm just always adding 4. You notice that the first number they have in common is 20. Lowest common denominator is 20. And in this case, you could have just multiplied it. Sometimes it works and sometimes it's not. So yeah, okay. So 20, all right. 4/5, how do we change it to 20? What's my big one? It's 4, right? 5 times 4 is 20, 4 times 4 is 16. The 3/4 times, what's the big one? 4 times what is 20? It's times 5. So the big one is 5/5. 3 times 5 is 15. 16/20 and 15/20. The 16/20 is bigger. All right, number 11. Find the common denominator. And you, like I said, you can multiply 10 times 6. That's a common denominator. That's an easy way out. It's 60 would be a common denominator, but it's not the lowest. So I like you to start looking for the lowest. So the lowest, I want to list all the multiples of 10, and then I'm going to list all the multiples of 6. And my pen is stuck. It's not listening to me. There it goes. Okay, so I'll start with the tens. Remember, it's all about the denominator. And 10, 20, 30, 40. I'll just stop here. 6, the multiples of 6 are a little harder, but I think that I know my multiplication tables. But if you don't, look it up, print one out. 30. They're the same. The lowest is the same as 30. So it's 30, right? So now we're going to change them. So what am I multiplying with? 3. 10 times 3 is 30. 7 times 3 is 21. And 5, 6 times what's my big one? 30 divided by 6 is 5. 5 times 5 is 25. 6 times 5 is 30. Which is the bigger fraction? 21 out of 30, 25 out of 30. No, I didn't do that on purpose. My pen sometimes does things, it has a little life of its own. So I have to, anyways, now it's not working. Hang on. There we go. Up, see? It's not working. Okay, so hopefully you understood that. Now remember, we go over it in class. Please make sure you are taking the responsible way and ask questions and say, I did not understand this and this in the textbook, in this book, and we will definitely practice more in class. So the next page is page 4, and it says it's notes. So now what do we have here? And part homework, notes, and there's part of it homework down here. Okay, follow your teacher's directions to find the sum. Remember, sum is the addition, when you add, when the result of adding. Okay, number 1, you have nothing there, so I'm giving you the example. 1/4 plus 3/4. If you have the same denominator, you just add the top. Same denominator, you simply add the top. Do not add the denominator, okay? So 4 out of 4 is 1. So it's a big one. Okay, so 4/10, these are examples, plus 6/10. Same denominator, 4 plus 6 over 10. You're not adding the denominator, you're just adding the numerator. 4 plus 6 is 10 out of 10, which is equal to 1. Correct? 5/6 plus 1/6. Same denominator, simply add the top. 5 plus 1 is 6 out of 6, which equals 1. And then 9 out of 16 plus 7 out of 16, 9. Same denominator, keep the denominator, 9 plus 7. 9 plus 7 is 16 out of 16, which is equal to 1. So what do we always add? To make it equal to 1. That's the question. So you added to make it a whole. You want to make it that whole. Yeah, so notice I'm going to make that a little different color. So you see where this is heading. Okay. Protein bars, what is that? Okay, so we have in this section here, right here, it's talking, you don't know that, I have that written down in my notes. How many protein bars do you have in all? Oops, not the good color. How many protein bars? So you have 2 1/3 plus 1 2/3 protein bars. Okay, so a picture, 2 1/3. Now the denominator tells me how many equal parts I need to divide each one by. So it's all the ones that are divided by 3. So I got 2 whole. So I got this one, and then I have 1/3. Okay, so that's a photo picture. Plus now I'm adding 1 2/3. So another 1. Again, the denominator tells me how many equal parts. So I have 1 whole 1 and 2/3. 2 parts shaded, right? So 1, 2, 3. So I know I have 3 whole protein bars, but I also have these parts. You can move the parts, these 2/3, you can stick right here. And then forget about this one. So I have 3 plus another whole 1. So altogether I have 4 protein bars. Okay. Another protein bar question, 1 3/5 protein bars. So you have 1 whole 1 and 3/5 of 1, plus 2 protein bars and 1/5 of 1. Okay, so I'm going to draw the picture out. So I have 1 whole 1 and a part of 1, but my denominator is 5, so I got to have 5 equal parts. 1, 2, 3, 4, 5. 2, 3, 4. 1, 2, 3, 4, 5. So I have 1 whole 1 and 3/5. So I'm shading 3 parts out of the 5 parts. And then plus the 2 whole 1s. And then a part of it, right? 1/5 of another one. Again, I have 5 equal parts, so now I have to divide 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Notice when I divide 5 equal parts, I have 4 lines that I'm drawing. Count those parts, okay? And then the last one is where it really matters. My equal parts, I'm having 1/5. 1 out of 5 parts is shaded. Okay, so I have 1 whole 1, 2 whole 1, 3 whole 1, and then this is the part plus this part. I'm going to stick this part over here and forget that one. So how many parts do I have? 1, 2, 3, 4 out of 5. Okay, hopefully that makes sense. And now your job is to figure these out. I want to show you the first one, but then after that, you're pretty much on your own. It says mental math. So really you can draw yourself these pictures, or you can try to figure it out in your head, which is not hard because a lot of these have the same denominator. See how you have the same denominator? You just add the top. 1 1.5 plus 2.5. You definitely can add the 1 and the 2. Mental math, you don't want to write it down. but I'm going to write it for you so you know what to do. 1 plus 2 is 3. 1/2 plus 1/2 is 1 whole. 3 plus 1 is 4. But this is, you're not supposed to write all this. You're supposed to do it in your head. No writing. Definitely no calculator. Okay, so try these out. Don't worry if you're not successful right away. Put a question mark next to the problems you can't figure out, and we will do them in class. And then number 10, I'm gonna, so this is homework right here, 4 to 9. And why would we probably not add 4/11 and 7/16 using mental math? They don't have the same denominator. You couldn't do it. You can use mental math with the same, so you would group these. So you would maybe regroup this 1/5 plus 4/5 plus 2/7 plus 5/7. So you can group the ones together with the same denominator, but if they don't have the same denominator, you can't do that in your head. So I'm going to say regroup. Okay, you can do that. Same here. Figure out this and leave that part alone. And here too, add your 3's and just kind of estimate how much more would that be. Okay. And then it's talking about the problem in the beginning that I said is an assignment for you. If you want to look at that again to see if your answer makes sense now, that's what this is about, okay? So check answer on page 1, I think it was. Okay, we're done with page 4. We're moving on to page 5. And what do we have here? It's notes. Okay, so we're now estimating, which is, remember, an educated guess. So definitely no calculator. You can use some pencil and paper if you like. All right, so follow your teacher's direction. That always means I'm coming up with some examples, okay? Record and sketch. Each rectangle represents one whole. So that's 1 and that's 1. So I'm shading in a fraction, which is, I'm going to write 1/9 and 1/11. So notice different denominators. So 1/9 is about this much. Maybe a little more. And 1/11 is even smaller. Like maybe this much, right? 1/9, 1/11. And so now we're going to estimate the sum and use the picture. So I'm going to draw these two together, right? This is 1/9 and then maybe 1/11. Might come up to here. Circle one number the sum is closer to. I would say your choices are 0, 1/2, and 1. This is 0, this is 1. Here would be 1/2. So it looks like, to me, that the answer is closer to 0. So it's a visual, right? To kind of visualize how much would be 1/9 of a whole when I shade it in. How much would be about 1/11? So really you would have to mentally divide this bar into 11 equal spaces and then pick the first one. So you can kind of imagine that's a small part, right? And then you add them together, those two shaded parts. Okay, next one is 1/15 plus 5/11. Notice not the same denominator. So 1/15 is a very tiny part, very, very tiny, but 5 out of 11 parts is, so you have to draw 5 of these. So my estimate is that it comes to about here. It's a little less than 1. No, it's less than 1/2. A little because 5 out of 11 pieces, if you take 11, if you have 11 equal pieces and you take 5, you almost have half. 6 would be more than half. 6 out of 11 would be greater than half because you would have more. Yeah, you'd only have 5/11 left. But 5/11 is a little less. So if you add these two, remember your choices 0, 1/2, 1. So there's 0, there's 1, that's your whole, and in the middle is 1/2. So your job is to decide if I add these two shaded parts, where would I end up? It's close to 1/2. And then we have 5/11 plus 6/13. So 5 out of 11 is close to 1/2, but a little less than 1/2. And 6/13 is a little less than 1/2 because you got 6 pieces. 6 out of 12 would make it exactly a half, but this is 13, so it's a little less than 1/2. So if you add these two, 0, 1, 1/2, you're going to be close to 1. Yep, close to 1. And now this one, 4/7 plus 3/5. 4/7. Is it greater than 1/2 or less than 1/2? Greater than 1/2 because you got 4 out of 7 pieces. Greater than 1. 3/5. You got 3 out of 5 pieces. That's also greater than 1/2. So when we shade, we have to go a little bit beyond 1/2. Just a little bit. And 3/5 also. If this is 1/2, we're going to go a little bit beyond it. And if I add these, oh, this is a different question. The sum, because they're all both bigger than 1/2, the sum will be greater than 1. So you have more than 1. Because both fractions are bigger than 1/2. Okay, and then the this part, my numbers that I made up are 3/7 plus 1/3. So 3 out of 7 is less than 1/2 because you got only 3 out of 7 parts less. Remember the signal. I want you to remember this means less. 3/7 is less than 1/2 because you only got 3 out of 7 pieces. So you got 4 pieces left. And 1/3 is also less than 1/2 because you have 1 out of 3 pieces. Remember, you got 3 equal parts, but you only got 1 of them. So you got less than 1/2. So if you add them, I'm going to draw that. 3/7 is a little bit below 1/2, maybe this much. And 1/3 is probably ends about right here. So if I add these two, the sum will be less than 1 because both fractions are less than 1/2. Okay, so we're kind of just estimating where would it be if I add these two shaded parts. I get more than 1. If I would add these two shaded parts, I would have less than 1. Okay, so now over here, without calculating, do not write anything down. Circle the phrase that represents the better estimate. So you're just closer to 6 or closer to 7. So 2 1/8 plus 4 1/9. So the 2 and the 4 are going to be 6. Those are your whole. But now you're also adding 1/8 plus 1/9. So your job is to think, is this going to be less than 1/2? Yes, it is. This is going to be less than 1/2. So if it's less than 1/2, then your answer would be closer to 6. Because if it's greater than 1/2, it would be closer to 7. I'm going to write these symbols again because I always want to make sure you understand them. Yeah, so you have them written down. Let's look here. 4 1/12 plus 5 2/21. So this is a really small part right here. So your whole numbers, 4 plus 5 is 9, but then you also have your fractions. 1/12 plus 2/21, again, it's less than 1/2. So it's all about the 1/2. 1/12 plus 2/20, very close to the very small parts, less than 1/2. So the answer again is closer to 9. Okay, if it's greater than 1/2, it would be closer to 10. So let's try this one. 1 plus 2 is 3, but then we have these fractions. 1/2 plus 1/11 is greater than 1/2 because you're already starting out with 1/2 and you're adding some more to it. Of course, it's going to be bigger than 1/2, greater. Yeah. So now we have an answer that's closer to 4. And the last one, 10 plus 10 is 20. And then we have to figure out 1/5 plus 3/7. That's a little tricky. Is that going to be less than 1/2 or greater than 1/2? This is a hard one because it's not so simple. And 1/5, I'm going to draw that out. This is 1/5. And then where are we? 3/7. So if you put that, that doesn't, I'm going to take a wild stab at it and say it's still going to be less than 1/2. Could be very close to 1/2. In my notes, I actually wrote greater than 1/2. So it could be hovering right around that value, a little bit over. So I'm going to have to go with my notes. I might have worked it out in on pencil and paper actually, and noticed it's greater than 1/2, but that's a very good close-up. This right here, it would push it over the edge of 1/2, greater than 1/2, questionable, okay? Again, on number 10, they're asking you to check your answer after you learn all these little things. Maybe your check and revise answer. I'm not sure if you need to revise it. You might have it perfect already. So this is kind of just reminding you, looking at that again. And then we're on page 6 next. And page 6 says homework. And I think all of that is something you can do. I'm only giving you clues on number 1 and 2 because you're supposed to match a picture with this problem. So this is 5 parts. So which one has 5 parts? It's actually the number line. This is called a linear model. Yeah, match the following equations with an appropriate diagram below: area model and then linear model. And the only one that matches number 1 in my book is this one. And why is that? Because we have 5 equal parts. Do you notice that? The 1/5 is this one. And then plus 2/5. 2/5. And then you end up at 3/5. So that would be D. And now this one is this 8 part right here, because you got 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. You got 4/8 and 3/8. And all together you got 7/8. So those are the ones that match. And these don't have a match. It says not all diagrams have a match. So you see that. And then your job is to answer the rest of the questions down here. Remember, when you estimate, it's just giving you an idea. Is it less than 10, greater than 10? And then mental math, you kind of grouping the denominators together. Okay, mental math definitely without a calculator. And again, if you have questions, please don't hesitate. We're going over it in class. And then this page 7 is notes. And I think that's the last page in this. Nope, one more. So let me take a little pause here. Okay, on this page it says draw diagrams and find the difference for problems 1 through 6. Remember, difference is the answer when you subtract, which is takeaway, minus. Write an explanation of this term in my word bank. We're already done that, okay? So notice same denominator. Sometimes it's just too easy and you don't need a diagram. And I don't want to make this any harder. If you have the same denominator, all you do is subtract the top. And then you're done. However, this is not in simplest form. This is not the lowest form. 2/10 we can reduce. And I want you to think what number goes into 2 and also into 10. And I'm going to look for that on here. If you have a good number sense, no need to go to your multiplication chart. So I'm looking for a column or row that has the 2 and the 10. Notice 2 and 10 are divisible by 2. 2 goes into 2 and 2 goes into 10. 2 goes into 2 one time and 2 goes into 10 5 times. So now we're on that page. So I'm dividing by 2. Another way to notice is that if your numbers are even, you can always divide by 2. But then you have to maybe do it several times. 2 divided by 2 is 1. 10 divided by 2 is 5. This is your simplest form, or reduced. Same denominator, no need to make it harder than it is. Keep the denominator, subtract the numerators. 5 minus 1 is 4 over 6. Notice, not in lowest terms. I'm going to divide by 2 because they're both even. Even numbers are 2, 4, 6, 8, etc. Yeah. The odd numbers are all the others. Okay, so I can divide by 2, and then I have 4 divided by 2 is 2. 6 divided by 2 is 3. Here we're going to need a little picture, I think. Okay, 1 is a whole. You can always draw it out with a rectangle. This is my 1. I need 8 equal parts. The denominator tells you how many equal parts. If I have 8, I start by dividing by 1, dividing in halves, dividing in halves. That definitely gives me good 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. I always count my parts to make sure I did it correctly, okay? And I'm taking away 5 of those. So if I take them away, let me shade them. 2, 3, 4, 5. So how much do I have left? 3/8. Okay. And we can do that here. I got a 1. Draw yourself a rectangle. Start out with any rectangle. I got to cut it in 6 equal parts. I can start with 1/2 and then these need to be in 3s, and this needs to be in 3s. 1, 2, 3, 4, 5, 6. I have 1 whole. I take away 5, 6. 1, 2, 3, 4, 5. What do I have left? 1, 6. Okay. Now we're getting a little tricky. We got 4 take away or minus 1/3. So now we got to draw 4 parts. 4 whole ones. 1, 2, 3, 4. You got 3 parts you have to divide every one in. 3 equal parts, and they need to be as equal as possible. Mine are not always that equal looking. So I got 4 whole ones. I'm taking away 1/3. Oh, so I'm just shading all of these. This is 1 whole one, 2, 3. This is my last one. I'm taking away 1/3. Oh, oh no, I didn't do that right. Nope. I need to go back. Sorry, guys. don't need to shade that. I'm going to just take away 1/3. This is what I want to do. So you got 4, you started out with 4 whole ones, you took away 1/3. So what do we have left? 1, 2, 3, and 2/3. Okay, 3 whole ones. Oh, we want it to look a little bit like equal to make it the appearance that we got 3 whole ones. We're taking away 2, and we have to divide into 3 parts. The denominator always tells me how many parts. Okay, so we're taking away 2, so I can already scratch out 2, and then 2/3. So what I have left is simply 1/3. All right, one more, 2 whole ones. Divide into 4 equal parts, start in halves. Take away 1, and then 1/4. So what's left is 1, 2, 3, 3/4. And the last one here, we got 3 whole ones. Two parts. Take away 2 and a half. What's left is 1/2. So that's a visual diagram to help you get started on these. Pretty soon we won't need that anymore. And here we go, mental math. And that's homework, by the way. So right here, try that yourself. And down here, without calculating, estimate each difference. Is it closer to 4 or closer to 5? This is also homework. Try it. It's okay. You only have 2 choices. If you get the wrong answer, we go over it, okay? We will correct our numbers, and hopefully my explanation in class will help you to understand it better, okay? But you got to try it yourself. And then on the last page of this lesson, it's all homework. Okay, and then we're done with lesson 1. Next one would be starting on lesson 2. Up here you can tell when it's turning, yeah, to the next lesson. So this lesson 1 is quite a little bit, so you know, get started on it and try your best.